First, we use that as the template, and I'm going to mark each place I need to drill a hole. Yeah, it will go around like that, and then we'll go around like that, and down through. Okay. Alright, that's all the holes. Wow, that's a lot of holes to drill. Alrighty. Okay, next thing we're going to do is we're going to prepare our wires. I need to have about 15 wires. 10, 12, 13. Right where it is. Alright, I've got all the wires straightened out here. Now, the first one I'm going to do is I'm going to do the head first. That's one of the most difficult parts to do. Now, we have to stick one into there, and I just got a piece making a loop here. And I need the other one. Just a little bit. Okay, there it is. There it is. It all looks perfect. The next thing to do is the glasswork. Alright, first thing we're going to do, we have to make up our envelope. Now, for that, we need it to be 2 inches in diameter on the inside to take the support. So, I got that set to 2.1 inches. I got some 1.5-inch tubing here. And we'll just blow that out a little bit to get it to be 2 inches in diameter. And the total length needs to be 5 inches. there's our envelope. It's just about the limits of what I can work on this lathe, and this torch has got both oxygen concentrators running full blast. That's about 10 liters per minute of oxygen, and you know, in fact, as hot as it'll go. So this is about the limits of what I can work with this setup. The lathe needs to be a little bigger, and I need a bigger oxygen concentrator. You really need about 25 liters per minute to do, you know, any serious large glass work. 10 is not going to make it. 20 to 25 is what you really need. Next thing we're going to do, we're going to put a evacuation stem on the top, on the end. Okay. Now what I'm going to do is I'm going to flare that tube out so that it'll fit good in that hole. See, by having a big end on it, it covers the whole hole up and it doesn't tend to close the glass off. .9995. Close enough to 2 inches on the inside. Alright, that's going to work. Okay, so we're going to make us a 12-wire pinch. To do that, we have to have a flare first. Okay, next we're going to make the pinch area. We're going to flatten it out so we can get the wires through it. Got a piece of carbon here, and I'm just going to heat it up and press that carbon in there to use for a gauge as to how thick it needs to be. All right. Alright, that looks real good. Alright, we're going to do the pinch. Now, here we've got one set up. We've got it set up here. We have a fixture that holds all the wires exactly parallel and clamped in place. And we've got our flare, and this is where the pinch will be. So we're going to go ahead and we're going to heat that up to red hot and do the pinch. See what happens. Well, of course, I forgot to turn the camera on when I did the pinch, but it's pinched. Okay. Now, what we're going to do is put that on the leak detector, and we're going to see that it doesn't leak, and then that's going to do it. You want to help? You want to be in the picture? Yes. Yes. Oh. Yes. You want to help test? Okay. You can help test. Okay, we got it pumped down, and we got the filament on, And I got some helium bubbling out of here. And we're just not drifting. I'm going to just pump her down in here. Aha! We don't get the slightest movement at all. Alright, now we've got this pretty much underway. Okay, what I did was I bent them 90 degrees and stuck them through holes in the piece of mica, and then took another piece and clamped it. So that takes it and holds these wires in the holes and leaves the ends of them sticking out here so we can weld on them. Now this is on the back. This is on the back. The front is here. The part that glows is here. And all of these connections have to be made in the back, because we got to take these and completely coat them with insulation so they don't glow. We don't want any of the connection wires to glow. We want only this front to glow. Okay, the next thing that has to be done is we have to weld all of these wires. And to do that, we're going to use this silver wire. It's a mixture of silver and nickel. Nickel silver, silver nickel, whatever. And we're going to go ahead and use that. I'm going to randomly connect the pins. We'll figure out which pin goes where after the fact. Right now, we're just going to connect them up in such a way that they're the easiest way to do it. Okay? So, the two outside pins, I'm going to go to these two right here. I mean, that's just a short little piece just right there. And that'll get those out of the way. Alright, so I'm going to need pieces of wire. I'm going to cut them. Alright, that's one side. And that's the other. Okay? Then, we need some of this tubing. And I'm just going to take it, get the right length. Okay? And over here. Yeah. Okay. Pieces of tubing. Okay, now I'm going to take that wire, put that right on there. And let's see, I got to get my foot down here on the pedal. Ready to go. That one broke off. I can barely make it. Okay, that's welded on there. Now I'll put the tubing. See, this glass tubing will stop that wire from glowing. We absolutely don't want it to glow on the back, or it'll detract from the way it looks. Okay, so there's the other one. Take it. Don't think it welded. It did. Okay, that's welded. Now we take this and we cut. And then this one, cut. These are expensive pliers, but they sure don't cut worth a darn. So now we have a piece of glass tubing with the wire connecting to that pin. Alright. Well, you get the picture of what I'm doing. I'm going to go ahead and get it mostly done. And because it's going to take an hour to do this, so therefore it's going to be too much on the video. Alright? You can see here we've got all the connections made. We go from each bottom pin to one of the elements in the Nixie. We just took and welded to each bottom point, and put a piece of glass tubing, and then connected it to the appropriate glowing part. Now we've carefully arranged it so that none of the parts with glass will glow. Because if that glows, oh boy, what a mess. The only other way would have been to have a non-transparent back plate. Something made out of a black or some other color material. I don't have anything. I'm not sure what could be done that would be non-conductive and yet not transparent. So it's easiest just to use a piece of mica and make sure all the rest of it doesn't go. This gets all of the glowing electrodes connected up, but we have to have an anode. Now the anode in the Nixie tube consists of a screen or a grid that completely covers the glowing electrodes. We need a very close spacing, preferably maybe 5 millimeters or so between the glowing element and the anode. So what we're going to do is we're going to make a screen that is going to be flat and have a grid spacing of maybe quarter inch or so, and that'll allow the light to come through. We won't notice it because we'll use thin wire, use this same wire that we're using for everything else, and we'll just make a grid out of that, and yet it'll provide the electric field that's needed to go ahead and provide the anode potential. Now this is for small wire. All we're doing is we're taking it and we're grabbing it on one end with the pliers and the other end on the other hand, and I'm just going to stretch it. Okay, so that leaves it very straight. Now for heavier wire, this is thin wire, so it's easy to stretch like that. For heavier wire, you take the end and put it in a vise, and then you get you like a hammer handle and wrap it around the hammer handle and grab it with both hands, and then just, pull for all you're worth. And you can straighten out number 12 bus wire easily that way. First thing we have to do is bend a frame. So it's going to go just kind of on the outside. Alrighty. Okay, there's our frame. Okay. This is our new capacitive discharge welder. It's in addition to our main power welder. This one here is used for heavy powerful stuff, and the capacitive discharge is used for the fine wire, because we don't want to burn through the wire. This one will burn through the wire too easily, so by using the CD unit we get one pulse and that's it. Doesn't burn through. Okay, now what we have to do is we're making a grid. It's going to start whacking this stuff on there. A foot near the pedal. Beautiful. Okay. Okay. There. So I'm going to need 2 holes up at the top and then 2 down at the bottom somewhere, which I already have. Okay, so 2 holes I got to drill up at the top. Okay, now we've got to put some little tabs of wire on there to use to hold the anode in place. Okay, I'm just going to take that and go through here. Okay. Well, that's not the way to go. I need to go the other way. Here we go. there. I should be able to get it. Here. Alright, now, I have to figure how it to be there. There. Okay, now that gets our anode in there. I've got to have insulation to put on all these connections down in here, along here. All of this has to be insulated so it doesn't glow. Alright, so we need some cement. This is what we use. It is a high vacuum cement. It's completely hardened up, so I'll have to put some water in there and get it liquefied. Okay, now we've got a fairly miserable but important job to do here. The wires that come up from the pinch up to the base of the tube, well, they all have charge on them, so they'll glow if they're left bare. So we have to paint them with an insulation. And what we use is this ceramic coating. It's just a ceramic type stuff that's got some glue of some kind in it, and we just paint those wires. And that takes and gets rid of the glow, okay? Okay, we're going to let that harden overnight, and tomorrow we're going to go ahead and seal it off and see what happens. I'm going to have to drill a hole through here for the anode wire. It's just... okay, this one here is ferociously rough. Okay, that went right through. There's all kinds of arguments about using water, using oil, using this, using that. Just dry works just fine. Diamonds are super, super, super hard. I'm just opening the hole up to where it'll take the glass bead. Okay? That gets our hole for our anode wire. Now that will be put in there when we do the seal. When we seal the bottom, we'll go ahead and have that anode wire sticking through there with a glass bead, and then once we get the flare sealed, then we'll go ahead and, while it's still red hot, we'll go ahead and seal the bead for the anode in there. It looks pretty good. Okay, we're going to let that dry overnight, and tomorrow we're going to seal it into the envelope. Okay, first thing we've got to do is we have to bead. We've got to bead up our anode connecting wire, because that's going to have to go through the envelope. So we have to have us a hermetic seal there. Okay. I got a little piece of uranium glass, and I'm going to make a bead. You can see we've got that just welded onto there, and then we've got our bead going right through the side there. Now when we do this flare, then we're just going to seal that bead and make it vacuum tight. And that gives us our anode connection and all the rest of our connections. Alright, next thing to do, we got to heat it up carefully and slowly. Now, of course, I forgot to turn the damn camera on when I was doing the base, but we had two little places where it was leaking. Go ahead and seal them off. That's one. The other one was right here. Pinhole leaks. Okay. There. Look at that, what's that? Did we get the little arc to it? It's one of the advantages of using Pyrex. We can go back and just heat the thing up again and work on it. If this was soft glass, we could not do this. It would shatter every time we did it. We'd have to put it in the annealing oven, bring it up very slowly. It would take hours to make repairs. Cool it down a little bit. Absolutely nothing. Alright, all the leaks are out of it. We're going to just go ahead and pump her down. And we're going to put it in the oven and bake it for half a day at 400 or 500 degrees. Get all the air out of it and moisture, and then we'll be ready to put the neon in it and test it. Alright, first thing we're going to do, we're going to blow the getters, because once we get gas in the tube, we can't burn the getters. The pressure will be too high. Pressure has to be way down below 1 micron to make the getters flash. First I'm just heating them up a little bit to drive the air out of them. We'll let the pump pull the air out. Alright. Now we're going to flash them. That didn't flash very good. Let's get some. Okie doke. That's all we're getting. That one didn't have much in it. Okay, it's at 23 torr and 1 torr of argon. Okay, that looks real good. We'll go ahead and seal it off. There it is. Okay. Now, we've got our circuit board laid out for the driver, and we're going to put our Arduino Uno right here, and then we got our high voltage transistors and resistors and stuff here, and our 12 connections that go to the segments on the Nixie tube. Okay, we'll go ahead and print this off. What we do is we print this on inkjet transparency. You don't want to use laser. Laser does not have the density necessary to make good lamps. The black density allows the light to leak through, and this will make it to where you have a lot of pinholes and stuff like that. Okay, and there's our artwork ready to go. And we'll take that and make it up. Okay, here we have our piece of circuit board with the artwork stuck onto it. When you do this, you want to be very careful to pay attention to which side is correct. You want to have it to where it's not mirror image. If you get the artwork on upside down, then you're going to be in real trouble. So you want to pay real careful attention when you put the artwork on the board. Okay, we put it all in the vacuum system, in a vacuum frame. Now, if you don't have a vacuum frame, sunlight will expose it in about 10 minutes. But you have to have a very good press on it with 2 sheets of glass plate. Take 2 pieces of window glass and tape it between it to where it is absolutely pressed down on the circuit board. If there's any gap at all between the artwork and the board, then you're going to get light leaking under it and it'll ruin. Okay, we have to let this lamp heat up. We have the ultraviolet lamp heating up. Takes about 1 minute. All right, we're at full brilliancy now. A pretty potent little dude. All right, now we expose it for 1 minute using that lamp. it's been 1 minute, and we just take her out, and it is well exposed. Now we develop it. Okay, we just have a tray here with the developer in it. We just place the board in there with the sensitive side up, slosh it around a little bit. There it is. Okay. Now, your developing solution is sensitive to air, so you don't want to leave it out. Immediately when you're done, put it back in a bottle and seal it up. Alright, next thing we do is we etch it. To do that, I've got an etch tank full of ferric chloride solution. It's just saturated ferric chloride solution. You just mix it in there until you can't get any more to mix. Now, ferric chloride eats all kinds of metals, everything. So don't use any metal when you're holding it. Okay, clamp it so that when you put it in there, the side to be etched is down. When it etches, the material that comes off is heavier than the solution, so it falls off. It falls off of the board as it etches. Okay, and we just leave that in there, and it takes it about half an hour. So we've got the board all drilled, and we just got to stuff it with parts. That's about all we got parts for, but we got our nice little board here, our Uno, and we got the high voltage transistors and stuff. And then once we get all the high voltage transistors in, we'll be able to pick the resistors for the segments to get them to glow the correct amount. Okay, doing the software for it, I've got the Arduino and all that stuff hooked up. And what I've done is I've gone ahead and I've got the code for each of the positions of the arms. And I just take that and I just put it in a simple output statement with a time delay between each statement, and that makes the cowboy dance. So I had a failure in the Nixie tube that makes it to where I have terminated the project before completely finishing it. Let me see if I can zoom in on it and I can show you what happened. It is a fatal error. Okay. See how the head went out? That's because an arc formed down in the bottom of the tube. The insulating paint got chipped off during the sealing process, and it makes it to where it breaks down at the bottom of the tube there, and that shorts out the connection for the head. All the rest of it works perfectly, but that little failure completely makes it to where the project is terminated. Oh well, that was a lot of work. Really cute, but okay, you win some, you lose some. We'll make up the little box for it to go in. This is the power supply that powers the little cowboy. Alright, we'll need 2 pieces of wood, 6 inches even. Alright, and a height will be, alright, let's go 3 inches. That should do it. Okay, 3 inches tall by 6 inches. All right. Alright, now this seems to be warm. Okay, the sides go on there like that. Okay, I guess we ought to put the ends on first. Boy, that heat glue, that is so convenient. It's so much quicker and more effective than wet glue. Okay, now I got to get a cord onto there. Okay, we don't want this to short in here, so I'm going to put some of this plastic so that we have no trouble with it shorting out. Okay, now that gets us our little box. Now this is going to mount right here. So I'm going to make just a little extension that comes up there that this will sit in. Okay, now our top box we go ahead and stick together. We got some pieces of wood cut here. All right, that looks good. We'll let that harden a little bit, and then we'll grind it off on the belt sander to make it nice and clean, and that'll take care of that. That'll sit right on the top. All right, here's our top box. Okay, now this should fit through here. If it doesn't, okay, it does. Okay, and that will fit on here like that. Okay. That's good enough, okay? That right like that. Oh, that looks good. That looks good. Okay, we're using shoe glue to stick it on there. We don't dare use the heat glue on the tube because there's stresses in that glass, and I'm afraid even the slightest little bit of temperature hitting it with 400-degree glue, whoo, it'll probably crack that tube in 1 second. So we'll just use this shoe glue. It hardens pretty quickly. In a couple of hours, it will be hard and hold the tube. Okay, that looks excellent. All right, now we're just going to let that sit for about a few hours there to go ahead and set up, and then that will have the tube mounted. Okay, this is hard. It's fastened in there. Now what I'm going to do, I'm going to use some what's called special walnut. It's min wax, just a cheap stain, nothing special. Got a piece of felt, and I'm just going to take it and I'm going to stain the box. Okay, that looks really good. Good enough. Okay, we'll let that dry overnight, and then we'll spray it with some clear lacquer, and we're going to be finished. Woo! Okay. Now we're just going to spray a little lacquer on this to make it look shiny, and that's going to be it. Now it looks good. Now we just let that dry, and that's the end of it. We're done. Okay, we're recording.